Okay, we've done the tip of the week with HomebuiltHELP. This is going to be the tip of the year. This is big. Well, it's not that big, but we're trying to get the vibrations out of our airplane. So we've got a prop balancer here. You can buy, different brands. We actually happen to rent one out at Viking in our shopping cart. But so we have one here. It's a suitcase with parts. It comes with a head, or basically some cables, and this is a Dynamically. We've got a couple of cables to hook up to it. The end of one of the cables is a optical pickup. Sends a little light out of here that reflects back on a piece of tape that we put on the back of the propeller blade. So when the propeller blade passes the optical pickup, it reads it as 1 RPM. That's one of the two pieces of information the propeller balancer will need in order to calculate and display the amount of vibration in the engine. The other piece is this little gizmo up here, which is an accelerometer, which of course now is part of your iPhone and used in a whole bunch of different things. But this one is made by Dynamically, and it is, they say, to mount it rigidly to the engine using some big hardware. They do show it going straight up and down for a Lycoming or horizontally opposed engine. They also say that it should be perpendicular to the cylinders, which the Viking being an upright engine at a 20-degree tilt, 90 degrees to that would be where we have the accelerometer mounted right now. And it should be up front on the engine, close to the maximum amount of vibration, which would take place the furthest away from the engine mounts, where the engine moves around the most. After that, you want to prep your spinner bulkhead with some studs, or if you have screws around your spinner, then you can use those as a temporary means to attach some washers, because you're going to want to run the engine, measure the amount of imbalance, and then you can either get really sophisticated and use the instrument, and it will calculate where you need the weight and how much weight to put on. We're going to use a very basic solution. Rather than having the instrument do all that, we're going to run the engine. We're going to put some weights on one of our studs. We're going to do it 6 times, which doesn't take very long, and we're going to find out which one of our 6 studs that makes the best improvement. And then we're going to increase or decrease weights until we get the best result.
We record the reading on the meter next to each stud that has the washer. For example, our next recording will be written next to this stud. We are simply advancing the washers from stud to stud and recording the vibration analysis from the meter after each run-up.
Now, why should you balance your propeller? We believe that with a home-built airplane, when it's all finished, all the effort that's been put in, it's definitely worthwhile to do the final touch. Once you get your pitch set on your prop, you get the cruise speed you want, find somebody that has a propeller balancer and have your propeller balanced. And the reason is, it's like night and day sitting in the airplane flying it. It runs smoother, there's less vibration on your avionics, but mostly it just feels better to fly the plane. Now, we are going to add to our spinner bulkheads a series of holes in order to make this easier. This one, we put 6 studs in there. They're screws, basically, so they're fully threaded from the other side here. We did want to put them in and put a jam nut on them, and we also Loctited them so that they're permanently installed. That way the spinner can be installed and be part of the assembly. And then all the parts are marked. There's a line here that shows, or a scribble basically, that this in relationship to the bulkhead in relationship to the blades, in relationship to the prop spacer, in relationship to the engine, and so forth and so on. And we maintain that relationship when we do any work in the future, and we use the same hardware and so forth and so on. Now, it wasn't very hard to balance it. Basically, we put 2 big washers. We just kind of started with something and put it on one of the studs, and we moved it around, and we wrote down here what we got for IPS, which is we read right off of the instrument. It told us what the imbalance was. And once we found the lowest point, which was right here, 0.27, it says right, it was written right here, we ended up playing around with more or less washers or weights at that same location, and we found that for some reason we ended up being very accurate the way we started out. We couldn't make it any better. And at that point we tried to just add a tiny bit of extra weight, 1 bolt over this way, 1 bolt over this way, and we found that to be slightly better putting 1 here. And it might not be, you know, generally accepted practice to just kind of like have weights in different places, because if you had enough holes or places to put the weights, eventually one location should be good enough. Well, we didn't have that luxury. We just added yet another, tried to add yet another screw hole over, and it was 0.05 IPS, which is as good as you're going to get this. It's in fact excellent. Of course, we then could have gone back and played around with, like, well, put more here and less here and all that. But, you know, we don't want to spend all day doing it, and we got the results that we wanted with just a few trial and errors. So we just called it good, and we have a nice, smooth, flying and running airplane engine in front of our airplane. Definitely worth doing. Should be really considered. You know, don't look at it as a luxury. In fact, it could turn your airplane into something like a Cadillac instead of, you know, something not a Cadillac.